Welcome everybody to part 2 of our series on building strong foundation for our livestock farms. I'm really glad you're here. It is time to start, so I hope more people will be coming, but meanwhile, we're glad you're here. Thank you for joining us. Tonight, we have some great topics to expand on what we did last week. I want to thank SARE for partially funding this, NCAT, the nonprofit that we work for, and the ATTRA Sustainable Agriculture program for supporting the rest of it. And I want to thank the NCAT Livestock and Grazing team for all their hard work on this. It's really great series, and I hope you'll join us for part 3 as well. It's good for us to know who's here tonight. So we've got a poll. It's just 4 short questions, and I'd encourage you to answer that. Let's see what we can learn about each other. So for those of you who just came on, I'm Linda Coffey. I'm an NCAT livestock specialist. We are just getting started with introducing ourselves and doing a poll so that we know who's here and kind of where you're at with your experience level and your land. And I'm ready to move to the next slide, Carlos. All right, so thank you for being here again. This is part 2. In class number 1, Nina Prater taught about the basic soil health principles. Justin Morris taught about grazing management 101, and Lee Reinhardt principles of compounding, diversity, and disruption. It was a really great class. If you missed it, it's okay because we recorded it and you can watch it later. Today, we are going to expand on that fundamental foundation, talking about water infiltration and soil structure. That's Lee Reinhardt. We'll be teaching that one. Justin Morris is teaching about land carrying capacity, and just like last week, he's recorded his session due to internet issues, so that will be a video. Linda Poole is going to teach about adaptive management and talk about the Soil for Water program, which is a super exciting thing that you all can participate in, and she'll talk about that. We like an interactive session, and it's harder to do virtually, but please participate in the polls and in the chat. If you have a question come up, if anything seems confusing, drop your question in the chat. The NCAT team is working in the chat to answer questions in a timely fashion. And I'm super excited for you to meet the NCAT team both this week and next. Our goal is that by the end of this course, you have the information and the connections that you need to help you be a good steward of your land. So that's what we're after. I want to encourage you throughout tonight, engage with us. Look for action steps that you can do on your own farm. So as you're listening to the teaching, jot down or put in the chat action steps that pertain to you, because you've got to bring this home, so to speak. Pay attention to the principles. It's not the specifics that matter. It's understanding the principles that are going to impact your place. So today is Veterans Day. And so I'm very happy to have Margot Hale with us tonight. Margot is a dear friend. She's also director of our Arm to Farm program, director of our Southeast office, and interim director of the NCAT Agriculture program. Margot is passionate about working with veterans, and so I'm going to turn the floor over to Margot to talk about that. Thank you, veterans, for your service. And from here on, NCAT staff are going to pass the baton to the next one. I will see you all at the end of the class to wrap up. Thank you for being here. Thank you, teachers. All right, Margot, thanks.
All right, thank you. It is good to be here with you all again. I sure enjoyed last week's class, and I know this week and next week's classes are going to be great. I did want to take a moment. One, it is Veterans Day, so I definitely want to recognize that and thank our veterans for their service. Our own Lee Reinhardt, he actually just came back to us at NCAT after being on active duty for the past year or so. So as Linda said, veterans are very dear to us, and we love all of our farmers and everyone that we work with, but we do specifically have training programs available for veterans, and I just wanted to make you all aware of this, whether you know of somebody or if you're a veteran yourself, or can pass these resources on to others. So Arm to Farm is a week-long training program for military veterans, and we are offering Arm to Farm trainings Over the next 3 years, we have about 20 or 25 Arm to Farm trainings planned. And so stay tuned to get connected to those. You can find all of our Arm to Farm information at armtofarm.org. We also have an Arm to Farm Facebook page, and also just being a part of our ATTRA newsletter and on our email list, you will get notifications when we have Arm to Farm trainings and other training programs and opportunities for veterans and helping veterans get connected to training resources and to each other. One thing that is going on right now is we have some funds available to provide scholarships for veterans to attend sustainable ag conferences. And this is specifically for veterans in the Southeast US. And you can find out more information on that at our Arm to Farm webpage, armtofarm.org/apply, and you can find out information about those scholarships that's going on right now. And so if you know of a veteran who would like to attend some conferences in the Southeast, and specifically that focus on livestock, those are things that we're supporting right now. So please check out Arm to Farm, like our Arm to Farm Facebook page, and let others know about this program that we also offer. And with that, Lee, it is your turn.
Very cool. Thanks, Margot. That's a great program. I've had the pleasure and the privilege to work with Margot on several Arm to Farms in the Northeast, and they're always really, it's an amazing week. So thanks for everything you do with that. Okay, I guess we're on our first slide. We're going to start digging into the content now. For the next hour, we'll be talking about some more of the soil health issues and breaking that out into some specifics and diving just a little bit deeper. One of the things that we were talking about last week, we were talking about the soil health principles and why they're important. And one of the major reasons that it's important to really build up our soil healthy with organic matter and proper management is for water use efficiency. How to keep the water that falls on your farm. So that's what we're going to be talking about for the next 10 or 15 minutes. Next slide. So the management that we do really influences the stability of the soil that we have to retain water, to hold nutrients for exchange between microorganisms and plant roots. And it's the soil's physical properties actually that describe how these parts construct an environment in the soil that is inhabited by plant roots and microorganisms and macroorganisms of all types. These physical properties are basically how the mineral fragment and the organic matter and the pore spaces are all arranged to form an aggregate that is held together by glycoproteins and such, gluey substances produced from microorganisms like mycorrhizal fungi. In a healthy soil aggregate, which actually kind of has the structural appearance like cottage cheese. As we'll see in the next slide, I've got a picture. But the minerals in the organic matter are arranged to provide pore space for water and for air exchange. And if you'll notice on the slide on that far right-hand diagram is a soil particle. And notice the arrangement of the particles in the pore space. You've got organic matter, you've got roots, you've got sand, soil, and silt particles, and they all come together, and through their interactions, the soil environment becomes a structure. And that structure is a suitable habitat for sustained life. The structure is made by microorganisms and is what gives it the soil all of its stability and makes it a resilient habitat for soil life, as well as doing things like preventing soil and nutrient loss through erosion and leaching. A lot more detail can be found on how good or bad management affects the soil structure in our ATTRA publications. We have 2 of them, Building Healthy Pasture Soils and Nutrient Cycling in Pastures, and those are available in the resource list that we'll be sending out tomorrow. So now, with that little bit of foundation, let's discuss a little bit more on the importance of pore space in soil aggregates. We'll go to the next slide. There it is. Good. So related to soil structure and a very important soil physical indicator is bulk density. All right. So bulk density is basically a measure of the pore space in the soil. Recall that the pore space, usually about a half or so of the space taken up in a healthy soil aggregate, allows for water and air exchange, in addition to providing space for root growth. So a good way to visualize bulk density is to think of the difference between a sponge and a brick, right? So the sponge has pores and passages, allowing water to soak up into it, right? Whereas a brick is solid and it has no pore space and probably would be the worst thing you'd want to use on your car wash in your car, right? If these examples were soils, it's easy to see which one would better accommodate root growth and air exchange. So through the liquid carbon pathway, which is basically the movement of carbon in the form of plant sugars between plants and soil microorganism, through the liquid carbon pathway, soil carbon comes to rest in a stable form called humus. And this provides habitat for microorganisms and contributes again to the nutrient and water holding capacity of the soil. So you'll notice that we've put those 5 management practices here on the bottom of this slide that we covered last week. Adopting these kind of practices that foster biological activity actually kickstarts the soil biology to start to decompose and sequester and utilize soil carbon, increasing that nutrient cycling and leading to improved soil structure with better water holding capacity, making those water and nutrients available when needed, especially during drought. And whether you're in the West and you don't get enough rain, or you're in the East and you get too much, we need to keep what we get and not have it run off. Okay, next slide. Okay, so speaking of running off, as you might expect, efficient water cycling goes hand in hand with effective nutrient cycling. The increased soil aggregation that you get, which is a byproduct of abundant soil life, will increase water infiltration rates and the soil's water holding capacity. So it'll be less likely to lose nutrients either through runoff or through leaching into groundwater. Another positive feedback loop will ensue. Remember our principle of compounding effects from the last session. Is an enhanced water cycle that will benefit the microbial populations that mineralize or make available the plant nutrients that are there. The water cycle is so integral to the nutrient cycle that one simple way to tell if you're cycling nutrients well is to perform a simple water infiltration test. And that's what you see on your screen right there. Very simple. Take a can, cut it about 6 inches, put 3 inches into the soil and put a couple of inches of water into it, and just time how long it takes to infiltrate. The longer it takes to infiltrate, the better infiltration you have. If it goes in very fast, it can leach. Also, okay, hold on. If you get less than an inch in an hour, you're really lacking in that type of soil structure that has the pore space. You've got more of a soil brick, right? So this is a good test that you can do on your farm at any time. Use it to kind of test out some of the management practices after time. See how your management is doing. Okay, let's go to the next slide. Okay, so let's take a look at a rainfall simulator. We've talked about infiltration, and this is a short video done by NRCS that I'd like you guys to look at real quick, and then we'll just kind of discuss it for a few minutes after. So Carlos, can you bring that video up?
One of the marks of a healthy soil is good hydrologic function. But what does that look like? We joined JB Daniel on a farm in Virginia for an up-close and personal view of good and poor soil hydrologic function.
When I work with farmers to talk about managing their livestock on the pasture, there's varying degrees of management. What we've done, I've gone and taken samples from 2 different pastures where the cattle are managed very differently.
Okay.
One being the far sample being continuously grazed, contrasting that to this controlled grazing situation. Very different above ground conditions,
Yes.
but that also translates into how these pasture soils function.
Okay, okay. What's next? Are we going to turn it on?
Let's turn it on. Let's make it rain.
All right, let's make it rain.
When the farmer's considering managing the production in his grazing system,
Yep.
the single greatest threat to the annual production of the forages in that pasture is available soil moisture throughout the growing season. Here where we are in the eastern United States, that summertime rainfall is critical. When we get a rain though, we may have gone 4 weeks, 6 weeks without one.
Okay.
And when we get it, it's a thunderstorm
Okay.
oftentimes.
Right, right.
So we might get 2 inches of rain in a 30-minute period. And an extremely hard rainfall event like that, a lot of it has the potential to run off versus being captured.
Okay, yep.
Whether it infiltrates in versus whether it runs off, a great deal of that has to do with what's on the surface, whether
Yes,
it be canopy, surface residue, and the soil structure at the interface of the soil and the air. We're able to really look at what's running off this pasture, these two different pastures, right side by side.
Yeah, yeah.
And we don't normally see this when we're out in the field. I mean, who goes out and stands in the rain while it's raining?
Right, right.
All this plant canopy and residue protecting that soil surface is breaking the impacts of those individual raindrops.
Right,
it's
right.
dissipating that energy, spreading it out, and giving it time to infiltrate in versus run off.
Right.
Whereas over there, as you pointed out, we've got open, bare soil intermixed between the plant bases, where it's hitting that, it's already predisposed, ready to erode and run off.
Yeah.
And it's sealing and running off much more quickly.
Okay.
The surface on that soil is saturated, and as this oscillating head goes across, there's a lot of splash action that you see with those impacts.
Right, now my pants are getting wet, so we better turn this thing off.
I agree.
Well, okay, JB, before we carry on, tell us about the rain gauges.
Basically, it's measuring right at about 2.1 inches of rain. Fell in, I don't know, it was 8 minutes. Just an extremely intense rainfall event. You know, they tell us that over the course of the year, for annual soil loss, we can lose up to 75% of the annual soil loss in one event. So we've got to manage our systems day in and day out, knowing that we're not managing for the regular, everyday, or normal rainfall event. We're managing to capture that rain when it's really coming down. You know, rainfall, that's a free resource. Yeah. How many free resources does a farmer have? Right. You know, fuel's not free, the seed's not free, the fertilizer's not free. Rainfall's free when we can get it, but we can't buy it on demand.
Great, thanks. So as you might expect, you know, that water cycling does go hand in hand with that nutrient cycling, and I think this rainfall simulator really kind of gives us a good picture of what's going on. Notice, like in the video, the extreme differences in water capture between the two types of management. There was the controlled grazing, rotational, taking care of the soil, and then there was the continuous grazing, where the cattle or the pasture. The overgrazed pasture had extreme dirty runoff, but also a lot of leaching, which is when excess water takes nutrients out of the soil and then into the nearby streams and rivers. The well-managed pasture had significantly less runoff and was much clearer, which means that it carried less soil off the soil surface, and a nice steady infiltration rate, which would allow the soil aggregates to capture and to keep the water for future use. So good soil tilth, or the formation of those aggregates, allows water from rainfall to easily enter the soil and provides pockets of air so that soil organisms can breathe, and pockets of soil organic matter that soil organisms can feed on. And bulk density, water infiltration, and water holding capacity all measure the physical characteristics affected by soil organic matter, aggregate stability, and the management practices that we employ based on those 5 principles that we had discussed. These are relatively easy to measure in the field using low-cost equipment. Compacted soils with a high bulk density restrict root growth. They limit the movement of water and nutrients into plant roots and favor anaerobic conditions that slow organic matter decomposition and produce all kinds of organic acids that can inhibit plant growth. So soils with low infiltration rates are susceptible to water runoff and erosion and tend to be drought prone. And similarly, soils with low water holding capacity cannot sustain productive plant growth for more than short periods of time during the onset of a drought. So we're going to go up to my last slide here. And we're going to talk about getting to know your soil with the idea of bulk density and water infiltration in mind. So in following the principles of observe, implement, and adapt, which Linda Poole is going to go into a lot more detail on later, it's good to get to know your soil too. It can be as simple as taking a shovel to the fields and just look what's there. So you can look for soil smell. Does it smell earthy? The feel of the soil. Soil with a lot of organic matter has almost like kind of a greasy feel to it. Look for the presence of earthworms. Look for the stability of soil clods or soil that clumps up in water. Do a simple aggregate stability test. Put the soil clump in water, see how long it stays together before it falls apart. Look for the length of time needed for water to soak into the ground, that water infiltration test, or you can just take a rod, a rebar, something like that, stick it into the ground. That's an indicator of bulk density or soil compaction if it goes in really hard or if it goes in really easy. There are various kinds of soil test procedures you can get into if you want, including standard nutrient tests, complex tests that look at water soluble organic nitrogen and carbon, microbial respiration, soil protein and glomalin, and a lot more. So these tests can tell you a lot about the biological activity of the soil, but there's something about digging a hole, maybe not like this guy's doing on the screen, but digging a hole and experiencing it with all your senses, noticing changes over time as the soil management principles are followed. So next, Justin is going to discuss assessing your land carrying capacity, and to answer the age-old question, how many animals can I graze on my farm? But before that, I think what we're going to do is we're going to do another poll. So is that something that you're going to take care of for us there, Carlos?
Yes, I'll bring that right up.
Awesome. And again, after the poll, Justin's going to go ahead and talk about, he's going to talk about carrying capacity. One of the biggest questions I often get is how many animals can I put on my farm? And that the answer is always, it depends, it seems. So there's a lot that goes into it, and Justin's been doing this a long time. He'll be able to give us some good principles to follow whenever we start thinking about, how do we figure out the carry capacity? What's going on there? Starting to get a couple of these in here. And on that first question, what is the single limiting factor your pasture is preventing sustained high productivity? There's that other one, write it in the chat if you have something else. If something else that wasn't listed is a limiting, like the major limiting factor on your pastures. Organic matter is limiting. Yeah, organic matter is limiting, and if we can get that grass to grow up and trample it down with animals, that's one way that we can just get that organic matter into the soil. Okay, Justin, you think we're done with the quiz here?
I think so.
Cool. Then I would like to once again introduce my friend and colleague, Justin Morris, and let him take it away.
Hello, everyone.
Right, thanks, Lee.
My name is Justin
Carlos?
Morris, and I'm a regenerative grazing specialist with the National Center for Appropriate Technology. Today, I'm going to talk about how you can determine the number of animals your land can sustain, or in other words, the land's carrying capacity. Carrying capacity is largely determined by the above-ground plant productivity, which is a combination of plant height and how close plants are to each other. But what influences that above-ground production? It basically comes down to 7 factors. They are sunlight, which provides the energy for photosynthesis; air, which includes nitrogen gas that seeps into the soil and is converted into plant available nitrogen; carbon dioxide, another gas, rises from the soil as a result of the respiration of soil organisms and enters plants so that photosynthesis can occur; temperature, both in the air and the soil, affects the rate of plant growth by allowing chemical reactions to speed up or slow down. Soil moisture, which is necessary to build carbohydrates and to cool the plant during hot periods. Soil moisture is largely determined by how much and how often rains or irrigation comes, as well as humidity, soil texture, and surface cover around the plant. Soil life, which makes all nutrients available to the plant. Minerals, which are necessary for facilitating chemical reactions and creating plant compounds. And past as well as current grazing management, which determines how severe and how often leaves are removed. While all the factors here are critical, grazing management is the one that we can change and can affect soil temperature, soil moisture, soil life, and mineral availability. There are several ways that we can determine carrying capacity. Here I've listed just a few of those resources. The first being the Web Soil Survey, which is a nationwide tool available to anyone in any state. Also the Rangeland Analysis Platform, which is geared primarily for those living in western states, including all the states from North Dakota through Texas, but does not include Alaska or Hawaii. There's also the Grazing Stick, which can take the information from the Web Soil Survey and the Rangeland Analysis Platform and ground truth it to your specific site and conditions. And then there are also grazing specialists available through the Natural Resources Conservation Service that can potentially provide in-person technical assistance. Here's the home page for Web Soil Survey, and you can find it easily by just typing Web Soil Survey in any search engine on the internet. We first need to find where we want to get an estimation of total forage production. Use the magnifying glass to zoom in where you want to look, or go to the quick navigation menu on the left and click on the drop-down menu arrow for address or state and county to quickly navigate to the area you want to see. Once you've zoomed in sufficiently to see the whole area you want to analyze, click on the AOI button to draw a polygon around the field or fields you're interested in. Once you've defined the field or fields you're interested in, you'll notice that the area will be crosshatched and you'll be able to see on the left the total number of acres inside the polygon you just drew. In this case, the area I drew was 368.7 acres. Now click on the tab above that says Soil Data Explorer. Once the Soil Data Explorer has been clicked on, the crosshatched map changes so that it shows soil boundaries. Also, the submenu of Suitabilities and Limitations for Use is automatically selected for you. Now go to the left menu area and click on the drop-down arrow for Vegetative Productivity. Clicking on Vegetative Productivity drop-down menu reveals lots of submenus. The one we're interested in is the one called Yields of Non-Irrigated Crops by Map Unit Component. Once you click on the drop-down menu for that, click on the View Rating button and click on the Basic Options drop-down menu to show what types of crops there's information for. Here we see that there's several crop options. Let's say, for instance, that these fields are dominated by orchard grass and red clover, so we'll pick that. Here's a colored map showing different levels of production based on soil type. Red is the lowest production, yellow is higher production than red, light blue is higher production than yellow, and dark blue is the highest production. Gray means there's no data for that soil map unit. If we scroll down, we'll see this table that contains the data we need to determine the annual carrying capacity. This table gives you the soil map unit symbol, soil map unit name, the rating in tons per acre, and the number of acres for that soil map unit, as well as the percentage breakdown. So, what is the basis for these rating values? See the finer print below in the red box. It says that these are the estimated average yields per acre that can be expected of selected non-irrigated crops under a high level of management. There are a couple key parts in this sentence that we need to pay attention to. The first is estimated average yields per acre, meaning that these numbers are not exact and are only to be used as a very rough gauge of what you might expect. The second key part of this sentence is at the very end, where it mentions that these numbers were generated from operations under a high level of management. What is a high level of management? Carrying capacity is determined more by past and current grazing management than any other single factor, which I alluded to earlier. If your land has been historically overgrazed and you're starting with something that looks no better than someone's lawn, then the values shown here will only give you a feel for what the potential might be if the future grazing management dramatically changes for the better, not what you have right now. Here's a revised version of the previous slide's table, but with a few additions to make calculations a bit easier. I added the two right columns so we can get total forage production for all 367.8 acres in pounds. Once we do the math for each map unit symbol, we get 431,000 pounds being produced over the course of the entire year. From last week's presentation, I mentioned research that was published in 1955 that showed that if no more than 50% of the top growth is removed, then root growth will be minimally affected. This would be applicable for environments with at least 30 inches of rainfall or irrigation. In environments that are less than 30 inches of precipitation or no irrigation, the 40 to 50% top growth reduction should be reduced to 25% or less to ensure there is sufficient ungrazed forage to maintain soil cover at all times. For this example, we're going to set that percentage at 50% since we're in a 45-inch rainfall environment in Boone County, Arkansas. Next, we need to insert what I call a safety or buffer factor to ensure we don't exceed the carrying capacity of the land in case the forage productivity estimates are considerably higher than the land we're interested in. It's wise to underestimate the amount of forage being produced or overestimate how much forage livestock are going to eat, so we're less likely to be overstocked and exceed the carrying capacity. Having more grass left over is always a nice surprise to have rather than running out of grass and having to destock or feed hay to avoid overgrazing the pasture. Since I always try to be conservative in my estimates, I'm recommending a 25% reduction, meaning that we're reducing what will be available for intake by 25%. Once we multiply the total pounds of forage produced by 0.5 and 1 minus 0.25, which is 0.75, that gives us 161,625 pounds available for intake. While the focus of this presentation is for graziers located in a 30+ inch rainfall environment, many of you may be operating locations that are much drier and where native rangeland or dry pasture is present. In such situations, the rangeland analysis platform is another tool to look at potential carrying capacity. Once you get to the home page, as seen here, click on the Production Explorer and Stocking Rate Calculator. This will allow you to select an area of interest similar to Web Soil Survey, but unlike Web Soil Survey, you'll be able to compare current year production to past years, quantify the amount above or below a long-term average, and get an interactive estimate of the number of livestock you can place in a field for a certain time period. This tool also allows you to see forage growth trends every 16 days during the growing season, including the year that you're currently in. Once we get an estimation of what might be out there using either Web Soil Survey or the Rangeland Analysis platform, how do we ground truth it to know what's really there? Well, one tool that's usually free and does a pretty good job is the Grazing Stick. The Grazing Stick can be easily used to estimate the total pounds of forage in a field or several fields relatively quickly. Shown here is our own Linda Coffey providing instruction on how to use this tool. So how does the Grazing Stick work to estimate forage production so we can determine carrying capacity? The most obvious way is by helping you to determine the average height of leaves in the pasture using the ruler. As you can see in the photo, one of the 4 sides of the grazing stick is marked in inches, so we can measure the height of the leaves. The other 3 sides of the grazing stick has additional information for figuring out the number of paddocks, number of animals, or size of area livestock can be allowed for a certain time period. If you don't have a grazing stick, you can use a yardstick or tape measure to take forage height measurements. When average leaf height is combined with plant density, which is how close plants are to each other, and the species of plants that are growing there, we can estimate how much forage is growing in a field at the time we are there. Additional information will be needed to estimate the total forage production for the year so we can estimate carrying capacity. Here are some broad guidelines when using the grazing stick. So when is the best time to assess forage production? While it can be done anytime during the growing season, the best time would be at the top of the elongation growth phase when plants are ready to be grazed for the first time. Since the grazing stick is only going to give us the forage being produced at that moment, we'll use growth curves to help us to determine how much more forage will be produced in the growing season so we can get a better estimate of carrying capacity for the whole year. When assessing a particular field, we want to, as much as possible, avoid biases to get better estimation. A couple of ways we do this is by walking across the field in a diagonal or zigzag pattern while taking leaf height and plant density measurements every 10 to 20 steps. When taking a height measurement, use the ruler side of the grazing stick. The average height is measured at the point where you feel very modest resistance from the plant canopy. Record the height for each sample location in the pasture. Plant density is the amount of ground surface covered with standing forage. We need to place the pasture into one of 3 density categories. This is the forage density meter, which is located on one side of the grazing stick. After taking a height measurement, slide the grazing stick underneath the plants so that it's as close to the ground as possible. Rotate the grazing stick so that the density meter is facing up. Look down through the canopy and count the number of dots visible. In the photo below, 2 dots are visible. Since 2 dots are visible, and if the field contains mostly orchard grass and red clover, from our web soil survey example, then we'd select the lower side of the range from the cell that's at the intersection of the column for 1 to 2 dots and the row for cool season grass with clover. So the value we'll go with for our estimation is 125 pounds per acre inch. That means that each inch of growth that we measure is 125 pounds per acre. If we measure 15 inches of above ground growth, then we'd have 1,875 pounds per acre of dry forage. Now, the reason I didn't go with the orchard grass row or the red clover row is because those are values when that's all there is. Since orchard grass is a cool season grass and red clover is a clover, then the cool season grass and clover row makes the most sense. Just for a quick example, let's say we took 20 height and density measurements on a 40-acre field the end of May. We want to find the year-long carrying capacity of that field. We found that in late May, there was 2,850 pounds per acre of forage. How do we estimate how much growth would occur for the full year and then convert that to carrying capacity? First, take the production we have so far of 2,850 pounds per acre and multiply that by 40 acres. That gives us 114,000 pounds of forage. Now, to figure out how much forage is likely to take place, we need to see a growth curve for the forage type we have. Here's a growth curve for an orchard grass and red clover mixed pasture. This data came from the Natural Resources Conservation Service and could be available through your local field office. Notice that by the end of May, in a typical year, 59% of the growth has already occurred. The value of 59% came from adding up the percentage growth for March, April, and May. Next, we take the 114,000 pounds of total forage and divide that by the percent of growth that's already occurred. Doing that, we get 193,220 pounds for the total season. Since this represents total above ground growth, we need to factor in the percentage livestock are going to eat and a buffer or safety factor. Allocating 50% for livestock consumption and a 25% reduction just to ensure we're not overstocked at the beginning, we get 72,458 pounds of available forage. Now that we've estimated that 40 acres has just over 72,000 pounds of available forage, we can determine animal numbers by knowing how much one animal consumes in a day or in a month. This chart I adapted from the Montana Natural Resources Conservation Service to show how much forage different kinds and classes of livestock need on either a daily or monthly basis. For operations where livestock spend weeks in the same field or longer, the month value column is more applicable. For operations where livestock are in a field for a week or less, even up to daily pasture moves, the day value column is easier to work with. Here's a continuation of the same table showing small ruminants. Now that we have an estimate of the amount of forage being produced on the example operation in total pounds, let's convert that into the total number of animals. In this example, let's say we are raising 1,000-pound cows that are grazing on pasture for 8 months and being fed hay for 4 months. We begin with the total pounds available for intake that we calculated previously, which is 72,458 pounds. Referring back to the table, we find that a 1,000-pound lactating cow needs 30 pounds of forage per day. One 1,000-pound cow with calf consumes 30 pounds of forage per day. 30 pounds of forage equals 1 cow day, which is the amount of forage one cow eats in one day. Now divide the forage available for intake of 72,458 pounds by the daily intake requirement for 1 cow day, which is 30 pounds, and we get 2,415 cow days of forage. Since this is the forage supply for only 1 day, we need to find out how many cows could be carried for 8 months, or 240 days. Dividing the forage supply of 2,415 cow days by the time on pasture of 240 days gives us a carrying capacity of 10 1,000-pound cows. This process would be repeated for every single field in the rotation until you had the carrying capacity for the whole operation. What if we had lactating ewes weighing 150 pounds? Referring to the table says that a 150-pound lactating ewe consumes 5.1 pounds of forage per day. Using the same method we used in the cow example, we find that the same amount of available forage would support around 59 ewes for an 8-month time period. While cattle and sheep have pretty similar dietary preferences, other ruminants like goats prefer browsing on brush rather than grazing on grasses and legumes. This needs to be taken into consideration when determining carrying capacity for animals that browse. When making land purchasing or leasing decisions, matching the forages on the landscape with the right type and class of livestock can save a lot of heartache and a lot of money. I've seen cattle ranchers purchase land that was perfectly suited for goats rather than cattle, with the idea to wipe out the brush and plant it to grass for cattle. But because they only wanted to raise cattle, they spent a lot of effort and money converting goat land into cattle land, and then more money trying to maintain it that way. So, some parting thoughts. Use online tools such as Web Soil Survey and the Rangeland Analysis Platform to serve as a rough guide, but ground truth it with an in-field assessment like the grazing stick, which is really a starting point. Despite past grazing management, future grazing management is the most important factor in determining potential carrying capacity. If carrying capacity is exceeded, overgrazing will result, which can negatively affect profitability. There are lots of ways to determine carrying capacity, including apps for a smartphone to do all the calculations for you, and even higher tech options that give you weekly forage production estimates for every field based on satellite imagery. Carrying capacity will vary from year to year based on temperature and soil moisture availability, which means that monitoring and adaptive grazing management are absolutely essential. Grazing specialists from the Natural Resources Conservation Service may be able to provide on-site technical assistance. Thank you for taking the time to watch this presentation. Feel free to reach out to me with any questions you might have. I'll now turn the time over to my colleague Linda Poole to talk about how we can know that we're not exceeding the carrying capacity of our land.
Thanks, Justin. What a wonderful presentation. A lot of meat in that presentation, and just in case you're like me and maybe looking at that and thinking that's a lot of math and I'm just getting started, is there an easier way? And there always is. What's good to know with the work that we're doing with regenerative grazing is you can always learn new things, and you already know everything that you need to know now to get started. And there's a lot of space in between the two, and there's a lot of help to help you think how to move forward. And we at NCAT are happy to be here to be part of that. My part of the talk today is to think about how to build on the foundation that Lee set by thinking about the soils and water infiltration, and what Justin talked about with thinking, what is your carrying capacity of your land? Next slide, please. Adaptive management is what bridges the gap between what we think we know and what we really need to know to do better in the future. It's a simple but essential process of learning from observation. We come up with a plan, we do the work, we watch to see what happens, we learn from that, and based on that, we replan so that as we go along, we'll always be able to come up with something better. Next slide, please. Observing how your grazing plans are playing out involves watching a lot of different players, including soil, water, plants, animals, people, finances, and facilities. Here's a sort of mental checklist that I have in my mind when I'm thinking about adaptive management in my program. So first of all, the livestock. How many do you have? Do you have as many in the pasture as you're supposed to have? Maybe you have too many. Maybe the neighbor's livestock got in there. So number is a good place to start. Health is another thing. Are there full rumens, nice bright eyes, clean backsides on your animals? Are they acting calm and content, or are they all riled up? Or maybe they're just pacing the fence in a circle looking for better feed. Good place to start. I pay a lot of attention to the wild things, and that's because one of the core principles of soil health is having a wide diversity of plants, animals, and insects to help land and livestock thrive. So what wild things are there at your place, and how are they getting along? Are there pollinators there? Are there plants for them to be able to utilize? What about dung beetles and earthworms, which are such powerful allies to us as livestock producers in building soil as well as livestock health? And we always need to be looking out for predators and parasites, the threats that can be out there too. So eyes open for those things. I look at plants as a way to assess forage conditions, much along what Justin's presentation just talked about with the grazing stick. We're thinking about how much feed is out there, but we also want to think about the quality of that feed. How green and nutritious is it? Are your animals grazing selectively? Are there particular plants that they're going after or that they're shunning? Are there weeds present out there that might be affected by your grazing or might affect what you need to do with your grazing? How about toxic plants? Some highly nutritious plants like alfalfa can also, under the wrong conditions, kill your livestock. So we really need to get to know the particular plants that our livestock are grazing. With water, how much do you have? Is it enough to water your livestock? Is it enough to drown your livestock? And how's the water quality? Hopefully there's not too much mud or any toxic algae in it. Some parasites thrive in puddles and wetlands, especially in warmer climates. This is something, again, where you really need to do your local research. For soil, in the resource section for this talk, you'll find a link to a webinar that Justin Morris did last week on a simple soil assessment with your shovel. That's all you need to be able to start to understand how healthy your soils are, what some of the challenges might be. And that goes back to some of the things that Lee was talking about too. As you're out and with your livestock thinking about the monitoring, another thing to look at is the soil surface. You know, are you seeing bare ground? Is there dust kicking up underneath the hooves of your animals for those of us in the dry old West? Or maybe down south or back east, the problem is that it's wet. Are you seeing pugging, hoof prints going down in your soil, maybe even displacing the soil, shearing the soil and displacing it? Something we really want to pay attention to. And of course, there's always the infrastructure. I run sheep, so I spend a lot of time making sure that my fences are in good shape. But we also want to be looking at stock water. And as it keeps getting hotter and hotter, with the temperature extremes we have, you probably want to be assessing whether you have shade in your pastures and whether you have shelters that can deal with inclement weather conditions. Next, please. So let's walk through adaptive management at my place in Montana. And the cycle of adaptive management starts with your particular context. And the context of my place is I have 320 acres of native range and tame pasture in northern Montana. We average 11 inches of precip annually with a range of 4 inches to 24 inches in a year within the last 15 years, but 11 inches, not much. Temperatures can range from 50 below zero to 113 degrees Fahrenheit. I run 80 to 150 fine wool, natural colored crossbred ewes, and sometimes some commercial cattle. My income comes from selling breeding stock, food, and fiber, and from a town job, which is this one, the fun of working for NCAT. Next, please. Probably the most important thing for anything that you do in agriculture is to set a holistic goal. And my holistic goal is to shepherd the prairie for full diversity and health of native plants and wildlife by using partnerships and regenerative practices that build a resilient property, business, and community. And with me, I'm a wildlife biologist by training as well as a range ecologist, and it's all about the wild things for me. Next, please. So what do I know, or do I think I know, about how to meet that holistic goal through my grazing program? I know that grazing practices affect not just soil and plant health and not just my financial health, but it also sets the stage for the many thousand beating hearts that there are on my place. This chart demonstrates that one size does not fit all when it comes to grazing practices and how those affect the grassland birds that I love. Next, please. From my goals and context, I develop a grazing strategy that includes tying together the carrying capacity of the land to my desired outcomes for the various pastures on my place. If you look at the bottom line of this chart, you don't need to read all this. It's just the information I keep for myself. But what you can see is the safe carrying capacity of my place has varied from 75 animal unit months to over 300 animal unit months per year, which means I better be out there monitoring. Next, please. So this comes back to what Justin was talking about assessing your carrying capacity. I'm lucky I'm in the West. I can use the rangeland analysis platform. Next, please. And as he said, it's a simple pasture, or it's a simple program that allows you to look at rainfall data and plant production from 1984 all the way through to today. And it even forecasts 16 days into the future. Next, please. And what we're seeing here is part of my place. I've drawn a little tiny polygon on there. It's part of one of my dry land pastures. And what you can see in the chart that's on the right-hand side is that over time, starting back at 1984, going through now, that top line is the herbaceous biomass. So that's how much potential feed there is out there for my sheep, my cattle, and my wildlife. And you can see a real nice upward trend with that. Next, please. By going one level deeper in the program, those blue bars are your rainfall. And one of the nice things about the rangeland analysis platform is you can match up particular rainfall years with production. And if you spend the amount of time that I do with these data, what you'll be able to see is I get a lot more grass for the same amount of rainfall now because of applying the regenerative soil health principles. So a lot of the gurus who talk about this is how to get a lot more ranch without having to buy any more land. And what this is showing me is that I'm able to do that. One of the things I really love is see that orange line that comes down, starts high and goes down. That's showing that the bare ground on my place has gone from over 35% down to about 5%. Based on the management that I've been doing. And that's something that you can see every day when you go out there, and it really pays back in productivity and with the health of our land. Next, please. So all of this sets the stage for my planning. And now what I want to do is talk about what, when, and how to monitor. First thing to think about, this talk covers monitoring your land and animals, but absolutely don't forget to monitor two more things. Pay attention to your finances. It is easy to do great things for your land and go broke doing it. And even more important, pay attention to the quality of your life and the quality of your family's life. How are you feeling? You know, if you're not feeling good, your land won't thrive. Always put that first. But now let's talk about monitoring the land. Let's go to the next slide, please. I like to look at year-to-year changes by using photo monitoring. It's so simple. You know, we all have cell phones now, smartphones, or a camera. We can take a picture, and it's so simple. You just find places on your property that are representative of what you have there, or that might be the first things that change, and you set up a permanent point and you have a look at what's going on. You want to take the pictures at roughly the same time of year. And I like to take pictures in the 4 cardinal directions. And then I like to take pictures straight down from as high up as I can get my camera, look down onto the ground. And if you have extra time, stretch out a transect tape, stretch out a 50 or 100 foot tape, and take 4 or 5 of those pictures in the same place looking down. And you'd be surprised at how much you can learn by just looking at a picture. Next, please. Here's some of the things that I've learned. This is a neighbor's property that I've been helping monitor for 15 or 20 years now. And this was a creek that had, it's a seasonal stream. And it was pretty much bare ground when we started. It's a creek, it's in Dry Hole, Montana. It's where wildlife and livestock come together. But what has happened over time is this property has really come up, and we can see by comparing pictures over years, you can see the streams start to weave back and forth. You can see the plants come up. You can see young cottonwoods come in, and it is so gratifying to look at these pictures over time. Next, please. We can also, by looking at these things, we can look at really small changes too. So we use permanent markings like this little stake. And the picture on the right, on the top, if you look right in the center of it, there's a little tiny sagebrush. And we learn a lot by what plants are producing seedlings and growing and which ones are becoming decadent and dying. The plant in the lower right corner is winterfat, which is a highly desirable and sensitive plant in our area. And another thing you can do with this is you can just think about, maybe I only have to track what goes on with a few plants to understand the long-term health of my property. Next, please. So that's how I look at changes over time. But really what we're talking about today a lot is what's happening right now. How's my grazing program going? And I make this simple. I make this fun. You can't do it wrong unless you don't do it. So my dogs count on me every day. It's the high point of all our days. Every day is to go out and walk through the pastures. And Justin described a process of making sure that you're looking throughout your whole pasture. I learned a technique called the Parker three-step. The Parker three-step, it sounds like a dance, but it's really just a way to walk across your pasture, and every 20 or 50 steps, look at what's at the toe of your right foot. And does that plant look about right, too short, too tall? A way to kind of see how you're doing on that. Is there bare ground there? Is there a lot of nice cover? All those things in that chart that I looked at that we talked about first, those are the things that I'm looking at when I'm walking through a pasture. So let's look at this next slide, please. Which this is the one of those things that you don't always want to show when you try to take good care of your land and your livestock, but this is my place. And I would like you all to have a look at this picture, pretend this is your flock and your place, and you're going out there with your dogs to have a look. What do you see? What's going on? Type it in the chat. Let us know what you see. What might you observe? Remember, we're looking at animals, we're looking at plants, we're looking at soil, we're looking at water, we're looking at infrastructure, we're looking at wild things. Thank you, Bill. They are healthy. Yeah, there are no poopy butts in there. Bunch of healthy young ewes. Yes, Nan, right. Yeah, and it is very different. This is the dry old prairie, yes. Forage, yes, definitely. That's something that we would want to be looking at and thinking about in this picture is there enough? Yeah, right, Linda. I do. I'm so proud of my girls. You know, about a 200% lamb crop. They're good girls. Yeah. So let's kind of think about what else we might look at. We identified that we're a little short on grass here. Yes, Casey, you're right. The shade is not in this pasture. Luckily, this is May and you can't really tell, but it's about 40 degrees. But yes, if they were in this small paddock when it was 113 this summer, those little lambs would be dying. Yes, good. Everybody, great observations. So let's look at the next slide, because here's something that I like to look at when I'm going is, I always start with the animals first. And this is not my place, but what do you see here? Go ahead and type it in the chat, please. Looks a little rough. Yep. Excellent. Excellent. We really want to pay attention to the condition of our animals. And the bright eyes, if you look at that goat that's on the right, look at those bright eyes and the head up and, shiny ears. If you look at the grass in these pictures, the irony is the grass looks a little bit better on the left than it does on the right. It's why we always need to keep not just one thing in mind. There's a lot of different things going on. Yes, the grass is always greener on the other side. Isn't that true? Yep. Okay, let's go on to the next one. So we know that we're going to look at the condition of the livestock. What would you see here? What do you notice if you were walking across your pasture and you saw this? This is one of my bum lambs out in my hay meadows. Yeah. Yeah, that is very, very green, very rapidly growing grass. At least here in Montana, when we have a bright growing green grass like that first thing in the year, we call it washy. It's like trying to build your health and your power on lettuce. A lot of water, not a lot of nutrition. So one thing that we might look for if our livestock are on this type of feed is you might look to make sure those backsides of the animals are staying clean, because sometimes that fresh green feed will just shoot right through them. Another thing is if you were in the South, down there where you are, and if you had this grass, which is about 6-8 inches tall, if you had been in that pasture within the last 30 to 40 days, there is a chance that you would still have parasites that could climb up that green grass, be ingested by that lamb, and then you've got a problem. Then you've got barber pole worm or problems like that. So yeah, rate of passage. So how fast the grass moves through the digestive system of the animal. Definitely an issue if you have really rapidly growing grass, which here in dry old Montana only happens for a little while in the spring, not in a year like this, but in a good year. Next, please. I like to look at the dung. I like to look at manure. I know it's weird, but man, you can learn so much. Look at the dung beetles in this. See all those holes? If you look down just to the right of center, there are 4 dung beetles, and there are 3 different species of dung beetles that are in this picture. They're really speedy little buggers, so I can't get a photo fast enough before they dive in there. But I look for dung beetles, and then I also look for the consistency of the manure. And I look for how it's distributed across the pasture, because that lets me know where my animals are hanging out. So I learn a lot from poop. Next, please. Okay, so you have that flock of ewes with little baby lambs, and this is the next pasture you're thinking about going to, because I don't just walk through the pasture my livestock are in. I start walking through the one they're going to go to see if it's ready. What do you see in this that you might consider if you were going to put in a flock of ewes with baby lambs? Yes, Nan, you're right. Yeah. My lambs aren't great swimmers, and it doesn't really look like it, but that creek is deep. The grass is wonderful. There's a lot of nice cover in there. The shrubs and the old grass from the previous year offer a lot of thermal cover for baby lambs. That's really great, but I'm going to have to be really careful that I don't drown lambs in that creek. Next, please. So we're at the end kind of where I was at. I just wanted to show you some of the bad things, some of the problems that I went out to monitor, and I went, oh my gosh, I'm so glad I'm out here, because if I hadn't seen this, bad things would have happened very quickly. I think I've already used up more than enough of my time, so I won't go through asking you what you see, but the upper left picture, my little guard dog puppy, he's brought his pals, a bunch of bum lambs. He's led them out from underneath the electric fence, and he's about to take them into a hay meadow that has not recovered the grass. If I graze the grass right now, I'm going to set it back. But what they will graze is the alfalfa. And we could kill that whole bunch of baby lambs by bloating them in one afternoon. So that's not a good one. Next guy over the upper right, sheep standing out in nice tall stuff and doing good work, eating weeds. But the problem with this weed is it's kochia. And in a dry year, kochia will concentrate nitrates. And nitrates can kill your sheep too. It doesn't always happen that way, but it can. So you want to be careful again and know your plants. Bottom left, it's not a problem that it's got all that cow manure and that the grass is knocked down. I did that on purpose. That's what I use cows for. My sheep are too careful. I need the bulldozer every once in a while, and that's when I bring in a herd of cows. But the problem was it didn't rain and it was really cold, and that pasture is not going to be ready to turn livestock in for at least 6 weeks. Plan B there. And the bottom right, that happened when I was managing a 60,000 acre ranch, 20 some miles long from top to bottom, and I hadn't got to the bottom. And I hadn't got there, but the neighbor's cattle had. And, my feed was gone and my water was churned up, and there's a problem for you. So next slide, please. What I wanted to invite you to do is to think about in terms of adaptive management and monitoring. Again, remember, it's practical, it's easy. Whatever you know right now is enough to get started. And there's a lot of help if you want to learn how to do more. And one part of that help is through NCAT. We have another group called Soil for Water within NCAT. We did a presentation last week. Justin Morris, Kara Kroger, Felicia Bell, and I did that. It will be in the resources that you can look at. That's where Justin's little piece on simple soil assessments with your shovel will be. Next, please. There's something really exciting this very day about Soil for Water. We have been, we started back in 2015 with some pilot projects in Texas, but this very afternoon, today, we opened our Soil for Water network nationwide and to farmers and ranchers. Up until now, it's been ranchers in 8 states. And today you can go to our Soil for Water website. And if you would like to become one of our network members, you'll be able to do that. And when you do that, you have access to a growing community of regenerative farmers and ranchers that are working together through peer-to-peer learning, sharing ideas, sharing experiments, sharing things that didn't go right, sharing their hopes, being able to access not just NCAT help, but we have a lot of great speakers that we work with, like Dr. Alan Williams, Gabe Brown, Nicole Masters, just a lot of different people, and that will be a way to access that. The website that we have right now has 2 sections that are not quite open yet. Stay tuned. Next week, we will have a forum where you will all be able to just post questions, post pictures, offer advice, seek advice, and start to build a community where we can all learn together. Next, please. And this is the team. So all the people who are talking tonight plus more, and we're spread all over the US, and we would be so happy to hear from you. And like I say, to support you in your journey to regenerative agriculture in any way that we can. So thank you. Linda, are you there?
Yes. Wow. I enjoyed Lee, Justin, Linda. I enjoyed your talks so much. Thank you very much. Carlos, can we put up that poll, please? That last poll. We have just a quick one, and I'm wanting you all, as soon as we kind of like wrap up my jabber, I want you to tell me about your action steps, because what Linda said about peer-to-peer learning, I believe in it. And when you say what one action step is that you will do, you're going to help somebody else think of one, and vice versa. So I hope that you all will share. So thank you for participating in this poll. This one is about action steps that I think are easy and logical when you're just getting started. You've heard us talk about NRCS repeatedly, and we will continue to do so. They are an excellent resource. Justin alluded to the fact that you can get them to help you figure out carrying capacity. He was a little careful about that because he knows, having been with NRCS for many years, that in some areas they're overworked. They don't have enough time to go to your place, but in other areas, ask, and they may. They can be super helpful with resources and help you find programs that can help with funding. So if you need help locating the NRCS, let us know. We can help you with your particular thing. But if you go to Google, they can also help. NRCS, go to your state and then find the field office that can help you. The map of your farm with pastures identified, you may have noticed from Linda's presentation that she's got them identified and by name. On my farm, we identify with number, and it really helps with communication. So NRCS can help you get a map of your farm, and I think it's a super thing to have. It helps you with planning, it helps you with record keeping, it helps you with communication. All right, thank you. Just to close it out, I thought those were super presentations. Thank you so much for bringing us so many great ideas. I am a strong believer that we can improve our land with livestock, but we have to manage for soil health. You learned tonight some things you can do to improve structure. And the big one that I heard again and again is keep an eye on that bare ground, right? Bare ground is not what we want. So let's try to think how we can manage to have less bare ground. Stocking the appropriate number of livestock. Not all of you are going to go through the math and the calculations like Justin showed you how to. If you're not going to do that though, start with a conservative number and then adapt according to your conditions. Do the monitoring like Linda showed you, and keep an eye on that bare ground and on your livestock condition. Don't have too many animals that your land can't support. I would encourage you to sign up at soilforwater.org, and I encourage you to come back for next class. We are all super excited about that. You've met a number of the NCAT team. You're going to meet more in that class. We're going to talk about choosing livestock for the farm, and we're going to do little virtual tours of NCAT specialists and their farms, because I think that examples of others really helps bring us more ideas, and because we're going to focus in about goals, which we recommend that you do as well. So thank you for being here. We have one evaluation. Evaluations are super important for our funder. They're super important for us too, to get feedback about what you liked and what you didn't. So thank you, speakers. Thank you all for being here. We will still hang on for a few minutes to answer some more questions. We are also available by email, and you can expect an email from us tomorrow with the resource list and I believe the PDF of the slides from tonight. The recording will come next week, and thank you so much for being here. Come back next Thursday. So I hope some of you are filling out the evaluation. Thank you. We really need this information. Thank you for your time. Yeah, yes, thank you, participants, for being here. Thank you, teachers. These specific questions about what you want more information about, this is great. Will you save the chat? We need to know, thank you, Dennis. Thank you all for coming. Do come next week. It's going to be a super fun class. Let us know what you still need information about. And by the way, I forgot to say, this team that you heard from tonight is doing an advanced grazing series soon. So stay tuned for that. If you are beyond the beginning stage, you're going to want to be in that. Could I see the resources slide, Carlos, please? Thank you. So you're going to get a resource page tomorrow. Lee is building it with input from Linda and from Justin, and it's awesome. I want to call your attention to a couple of things. The adaptive grazing you can do it blog, Lee did. It's got videos. It's super, super helpful, and it's great. The managed grazing tutorial, if you are truly at a beginning level, even if you're not, the managed grazing tutorial is 8 modules that the livestock team did some time ago. It's super. It starts with the beginning and the goal setting and the infrastructure and takes you all the way through monitoring. It's really great. It's got quizzes. They're short lessons, narrated, and feedback from them has been really good. The regenerative grazing web pages will take you to podcasts and blogs and publications and videos that are completely on this subject. The monitoring checklist Lee made some time ago as part of his grazing planning manual, and I like it so much. It's a standalone thing. You're going to get a link, be able to click right into that front and back checklist. It's super helpful. The monitoring protocols are coming out tomorrow, and I wonder how many of you subscribe to On Pasture or know what On Pasture is. Put that in the chat if you do. Kathy Voth is the person who runs On Pasture. It's a weekly magazine. The reading is always worthwhile. And they've got a number of ebooks, a Grazing 101 ebook that's fantastic. You're subscribed, Beth? Yeah, me too. It is money well spent. It's not very expensive, and I love supporting the work that she does. It brings in stories and articles from people all over the country, videos. It's really great. And you've got access to all the archives when you subscribe. So this is just a handful of the resources. You're going to get a lot more in the resource page that Lee did. Thank you, Lee, for doing that. I think I'm done. Thank you all so much. If you had action steps that you thought of, I'd love for you to put them in the chat. And I think look at your soil is a really good one. All right, thank you, team. Really appreciate your work. These were fantastic presentations, and I just appreciate you so much. Any questions for Lee or Justin or Linda? I'm okay with you unmuting and asking. Or put them in the chat. Kennedy, Non's gonna get a grazing stick, good. And verify organic matter in the soil.
One thing that we is we love to have conversations with farmers and ranchers across the country. If you have any ideas, comments, you want to walk something through, give us a call, an email. We're happy to chat.
Yeah, absolutely. And if you have some topics you want covered in that advanced grazing series, please feed those to Lee or Linda or Justin, and they'll get right on that. It's going to be super. And I said I would say goodbye and good night at 6:30. So everybody, thank you for your time. Thank you for being here. Reach out to us. You have our emails, and we'll see you next week. Thank you.